Good day, everyone. Today we're presenting our capstone, Water Conservation for Residential Housing with Application of Internet of Things, under the guidance of Sir Randy R. Otero. And thus we introduce ourselves, Rex Vincent Santos, Justin Vailoses, and Rainier Pastorpide. And for today's agenda, we will introduce the research, state the statement of the problem, present the system presentation, conclusion, and recommendation.
So the Philippines continues to face water shortage due to urbanization, population growth, and climate change. To address this, our study introduced an IoT-based water conservation system that collects and monitors rainwater for household use like cleaning and gardening. By using sensors and IoT technology, the system provides real-time monitoring of water levels and leaks, helping homeowners manage their water consumption efficiently. As stated by Agnes C. 2025, many regions are projected to face negative water balance. Through this project, we aim to promote water efficiency and support environmental sustainability. Rex Bakla.
I will now discuss the statement of the problem for our capstone project, which is divided into two parts, a general and specific problems that our study aims to address. Firstly, for the general problem, the United Nations has set sustainable development goals to help countries address global challenges, including ensuring access to clean water and sanitation. The Philippines is committed to these goals, but water shortage remains a critical issue affecting both urban and rural areas. According to our research, water scarcity in the Philippines is worsened by climate change, rapid urbanization, and watershed degradation caused by deforestation and mining. These factors disrupt water supply and increase demand, creating negative water balance scenarios in certain regions. In response to this problem, our study focuses on developing an IoT-based water conservation system that utilizes rainwater harvesting for residential housing. The system is designed to collect, filter, and monitor rainwater for non-potable use such as gardening, cleaning, and toilet flushing. By providing an alternative water source, our system aims to reduce dependence on municipal water supplies and help households manage water more efficiently during shortages. Now moving on to the specific problems in which to successfully develop and implement our proposed system, our study seeks to answer four specific research questions. The first question is, what are the stages undertaken in the development of water conservation for residential housing with application of Internet of Things using RUD? This question addresses our development methodology. We need to document and present the specific stages we follow using the RUD framework, from initial planning and requirement gathering through user design and prototyping and construction and testing, to final deployment and cut-over. Understanding these stages will help validate our development process and provide a replicable framework for future similar projects. For the second specific question, how is the Internet of Things integrated in the development of water conservation for residential housing using Internet of Things architectural layer? This question focuses on the technical implementation of IoT technologies in our system. We need to demonstrate how we integrate various IoT components such as sensors, microcontrollers, network communication, and cloud services using a layered architectural approach. This includes the perception layer for hardware sensors, the network layer for data transmission, and the application layer for user interface and monitoring. For the third specific problem, what is the software quality evaluation for residents and IT practitioners using ISO 285-010 in terms of functional suitability, performance efficiency, usability, reliability, and security, and etc.? This question addresses our evaluation of our system's quality and effectiveness. We need to assess how well the system performs based on internationally recognized quality standards. The ISO/IEC 25010 framework allows us to measure the system across multiple dimensions, whether it functions correctly, performs efficiently, is easy to use, operates reliably, and protects user data securely. This evaluation will be conducted through demonstration sessions with residents and barangay officials who will provide ratings and feedbacks. For the final specific problem, what is the implementation plan in the developed water conservation for residential housing with application of Internet of Things? This question focuses on the practical deployment strategy. We need to present a clear plan for how the system will be implemented in real-world settings, including deployment, location, target users, cost consideration, maintenance requirements, and scalability potential. Our implementation at Barangay Bambang's multipurpose area serves as a pilot test to gather insights for broader community adoption. Now for our system presentation. As of date, this is currently our working prototype tank. The filter consists of the following layer: hydrophobic wool, sand, another wool, charcoal, wool, and pebbles. The process will go as the following. Rainwater will go through the filter tank. So, it would first pass through the filter, and the filter is directly connected to the pipe that is connected to the filter tank. Moving forward is our landing page. The landing page, it consists of multiple features or information about our system, and as well as our terms and service and data privacy policies. When you press login, you will be directed to the login page. Upon pressing sign up is the register page, and here you can register your account to the Consrv application. Our Supabase will send a 6-digit code to your email, and just like that, it is verified. And thus, you may now proceed to the home dashboard upon logging in. Upon logging in, you will be directed to the onboarding for the system to set up your following details in your device identifications, like your tank ID, your device ID, device token, sensor settings, etc. You can change your theme, and you can also see the live details of your tank. Now in this section, you can see a side-by-side or a minimized version of the dashboard on top and the physical hardware on the entire screen. You can see how the dashboard changes dependent on what the sensor says. In this part, you can see the outflow pipe, or you can also call it a drainage, in which you can connect whatever you want. For instance, we connected a faucet. You can also connect your own tubing, you can connect your own pipes, etc. And as you can see, it will also update based on what's happening in the real world. Now for our following new features, for instance, a weather forecast, which we use a third-party API to forecast the weather based on geography. Now for the relay module, in which you can override the control from the automatic system, in which in any case the pump malfunction, you can prevent any damages. And you can see the ESP32 and its device status and the battery level. Now for the calibration settings, in which set up by the onboarding. Here you can change different calibration for your sensor settings. Then for audit logging for changes, for instance in the tank, for water leak, and user changes. Now for the conclusion and recommendations stated by Rainier Pastorvide.
For our conclusion, our IoT-based water conservation system successfully demonstrates how technology can play a key role in promoting sustainable water use. The system helps households conserve water and manage alternative sources more efficiently by collecting and using rainwater for non-potable purposes such as cleaning or gardening. This reduces dependence on municipal water supply. During testing, the prototype showed reliable performance. It provided real-time monitoring, stable data transmission, and accurate leak detection. Our collaboration with Barangay Bambang in Pasig City also proved that a low-cost IoT solution can provide real and practical benefits to communities. Overall, our study confirms that IoT integration is an effective approach to promote sustainable water management and supports future initiatives for smart residential systems. Based on our findings, we have several recommendations to further improve and expand the system. First, future integration into indoor plumbing can help automate water reuse and make the system more convenient for households. Second, we recommend water deployment and collaboration with local government units to extend the system's reach and promote sustainable practices across communities. Third, the use of machine learning and advanced monitoring can enhance data analysis and optimize water usage patterns over time. Next, we suggest implementing community training and awareness programs to ensure that users understand proper system operation and importance of water conservation. We also recommend dashboard improvements to make the interface more user-friendly and easier to interpret. Finally, continuous research on cost-effective sensors technologies is needed to maintain affordability and scalability, making the system more accessible for wider adoptions. These steps can help advance the project and contribute to long-term sustainable water management in smart residential communities.
That is all, and thank you for listening.